Charles Babbage was an English mathematician. He lived in the 1800s, a time of great invention. He had a truly big idea. He wanted to build a special kind of machine. This machine would be able to calculate numbers all by itself, automatically. He first called this concept the difference engine. Its main purpose was to produce accurate mathematical tables. Such tables were very important for things like sea navigation and complex engineering projects, reducing human errors. Babbage then imagined an even more powerful and complex machine. He gave this new concept the name analytical engine. This machine was incredibly revolutionary for its era, a real leap in thinking. It was designed to have an arithmetic logic unit, which Babbage called the mill. It also featured control flow, allowing for conditional branching and loops, much like modern programs. Furthermore, it had components for memory and for input and output devices, all fundamental parts of the computers we use today. A brilliant mathematician named Ada Lovelace worked very closely with Charles Babbage. She possessed a unique insight into his work. She understood the profound potential of the analytical engine perhaps even better than Babbage himself. Lovelace wrote extensive and detailed notes about this amazing machine. In these notes, she carefully described how the analytical engine could be programmed to perform various tasks. Many historians and computer scientists now see her as the very first computer programmer, a true visionary. She imagined it could do more than just calculations, perhaps create music or graphics. Actually, building these incredible machines was extremely difficult during the 19th century. The available technology and manufacturing precision were quite limited for such ambitious designs. Charles Babbage faced numerous challenges, including securing enough funding and overcoming technical construction hurdles. Sadly, he never managed to fully complete his grand mechanical calculating machines in his own lifetime. However, his meticulous plans, detailed drawings, and innovative concepts were exceptionally important. They became a vital source of inspiration for the future pioneers who would eventually build the electronic computers. The early part of the 20th century brought new and urgent needs. The outbreak of World War II in particular demanded much faster and more complex calculations. These calculations were crucial for things like creating artillery firing tables and for the secret work of code breaking. The existing mechanical calculators, while useful, were simply too slow and cumbersome for these massive tasks. Scientists and engineers began to seriously explore using electricity to power calculations. This shift led to the development of the first electronic computers, vastly different from Babbage's mechanical dreams. ENIAC was one of the very first of these electronic giants. Its full name is Electronic Numerical Integrator and Computer. It was constructed at the University of Pennsylvania by John Mauchly and J. Presper Eckert. ENIAC was absolutely enormous in size. It filled a very large room, stretching across many cabinets packed with wires and components. It used thousands of vacuum tubes as its main processing elements. These vacuum tubes generated a lot of heat and frequently burned out, requiring constant maintenance. Programming ENIAC was a painstaking and laborious process, often taking days of rewiring and setting switches. Following the development of ENIAC, another important machine called UNIVAC emerged. UNIVAC stands for Universal Automatic Computer. It holds the distinction of being the first commercial computer produced and sold in the United States. It was also designed by Mauchly and Eckert, the creators of ENIAC. UNIVAC was specifically intended for business data processing tasks. For instance, it was famously used by the U.S. Census Bureau to help process population data more efficiently. UNIVAC clearly demonstrated that computers could be highly useful tools beyond the realms of science and military applications. Alan Turing was an exceptionally brilliant British mathematician and logician. He made truly monumental contributions to the theoretical foundations of computing. He developed the abstract concept of the Turing machine. This is a simple yet powerful theoretical model of a general-purpose computing device. It helped to formally define what computers could, in principle, do. Turing's groundbreaking work was also absolutely vital in breaking complex German codes like Enigma during World War II. His efforts significantly impacted the war's outcome and shortened its duration. Computer technology continued to change and advance at a very rapid pace. The bulky and unreliable vacuum tubes were soon replaced by much smaller and more efficient devices called transistors. Transistors were a major breakthrough. They were smaller, faster, generated less heat, and were far more reliable than tubes. Then came another incredible invention, the integrated circuit, often called the microchip. These tiny chips could pack many transistors, and later millions, onto a very small piece of silicon. This miniaturization made computers significantly smaller, more powerful, and crucially much less expensive to produce. In the 1970s, a revolutionary idea began to take hold: the personal computer. Enthusiastic hobbyists and electronics fans started to experiment with building their own computing machines. One of the most famous early computer kits from this era was the Altair 8800. People would buy this kit and then carefully assemble it themselves. This sparked a tremendous amount of excitement and innovation. A new community of passionate computer enthusiasts was born. These individuals dreamed of having computers they could use in their own homes, not just in big labs. Two young visionaries, Bill Gates and Paul Allen, saw a massive opportunity in this emerging field. They firmly believed that software would be absolutely key for these new personal computers. They founded a company that would soon become a household name: Microsoft. Their first major product was a version of the BASIC programming language specifically created for the Altair 8800. This made it much easier for ordinary people to write programs for their machines. Microsoft's ambitious vision was to put a computer on every desk and in every home. Around the same time, Steve Jobs and Steve Wozniak founded Apple Computer. Their primary goal was to make computers that were incredibly easy to use and accessible to everyone. Their Apple II computer became a phenomenal success. Unlike many kits, it came fully assembled and featured a user-friendly design, including a keyboard and screen. It appealed to ordinary people, not just technical experts or hobbyists. Apple effectively showed the world that computers could be powerful and transformative tools for everyone, for work, for education, and for unleashing creativity. The next truly transformative step in computing history was connecting computers together. The internet fundamentally changed the world. It allowed computers located anywhere to share information and communicate with each other almost instantly. The development of the World Wide Web, with its graphical browsers, made the internet accessible and easy to use for millions of people globally. Suddenly, people could send electronic mail, browse countless websites, and find vast amounts of information with just a few clicks. This created a global village, transforming communication and access to knowledge forever. With the rise of personal computers and the internet, software development experienced an explosive boom. Many new and powerful programming languages were created by innovators. Developers around the world began to build all sorts of applications and programs. These applications ranged from essential office tools like word processors and spreadsheets to complex and immersive video games. The software industry rapidly became a major global economic force. Open-source software, where code is shared freely, also became very popular. This collaborative spirit further fueled rapid innovation and development in the tech world. Today, the computers we use are incredibly powerful and integrated into nearly every aspect of our lives. Artificial intelligence, often shortened to AI, is currently a major focus of development and research. AI enables computers to learn from vast amounts of data. They can now perform tasks that, until recently, required human intelligence and judgment. We regularly encounter AI in everyday applications like voice assistants such as Siri and Alexa. It is also critically used in complex areas like online recommendation systems, medical diagnosis, and the development of self-driving cars. AI is truly changing how we live and interact with technology. The future of computing promises to be even more exciting and groundbreaking. Scientists and engineers are diligently working on developing quantum computers. These new types of machines, based on quantum mechanics, could potentially solve immensely complex problems that are far too difficult for even the most powerful supercomputers today. Imagine discovering new life-saving medicines or creating revolutionary materials. Cloud computing is also continuing its rapid growth, allowing users to access powerful computing resources and storage online. The remarkable evolution of computers is certainly far from over. New breakthroughs will undoubtedly continue to shape our world in amazing ways.